All right, guys, so let's get back into it. So, is anybody paying any attention at all to politics at the moment? What happened last night, for example? There was a debate.
Much smaller though.
Thankfully.
Yeah.
Unfortunately, CNN did it, and they suck at asking good questions, and they like to create all kinds of drama that don't really exist. Anyway, let's not get too deep into that.
They're better at controlling the time, though. Some of the other networks.
Unless you're Amy Klobuchar, but we won't get it. I'm not done talking. Sorry. If you like Amy, that's great. I didn't say anything bad about her. I'm just saying CNN likes to let her talk. I don't know why. And then Biden, of course, cuts himself off. About 3 minutes away from out of time, I better stop. If you don't know these names, I'm a little worried. Anyway. Very often, this is not the only place this happens, but very often, especially right now, you see a lot of polls out, right? And I think I addressed this the first day or the second day. Very often when you see information about a poll, you'll see, let's say, Biden, Warren, Sanders, that's the big three, and maybe Buttigieg. Let's say that right now, 28% want to vote for Biden, 14% from Warren, 15% from whatever the hell it is. Let's say there's a poll that says this. What's at the bottom of the screen or somewhere that kind of identifies that they're not sure about it? It was built up of a sample, so there's no way they could be certain that this percentage of the country wants to do this. Yeah, margin of error. So down the bottom there'd be a little tiny, normally it's about 4% or so, depends on the sampling method and how large of a sample. That plus or minus 4%. That's exactly the error, plus or minus error. But this is about percentages. All we've done so far is about means. So we need to create a formula for confidence interval for a percentage. This happens to be section 8.3. And the reason I do 8.1 and 8.3 and skip 8.2 at first is because section 8.2 is going to use a different distribution that requires a new chart. 8.3 uses the same z-score distribution, so I like to do those together. So how do we create this formula? We actually do the same thing we just did earlier. We start with the same basic idea. We start with this. You're not the best. No way. All right, sweet. You're not the best either. You're the best. All right. So if I'm talking about, first off, there's a couple of interesting things. So if I am taking a poll and I want to see how many people are going to vote, what percentage of people will vote for Biden, let's just say. What two possibilities are there? Either they are or they aren't. So that sounds like what kind of distribution? Binomial. So they're normally, no pun intended, we have N, P, and Q. This hasn't even come up yet, but P and Q are the population percentages, the population probabilities. If you look back at every NPQ problem we've ever done, it's stated in such a way. 14.1% of all Americans do this. Population. Okay. So what we're going to do is, if we go out and we want to figure out how many people are going to vote for Biden, we can't talk to everybody, so we just talk to a sample. So we need to figure out a sample probability of success and a sample probability of failure. You're really going to love this. So this is population symbols. So for the sample, this is going to kind of make some sense. What's the sample mean? No, what's the symbol for the sample mean? Sorry. X with a bar on it, right? It's got a bar on its head. So the symbol for sample probability success and failure is P and Q wearing hats. And that isn't just me. That's the actual name of the symbol, P hat and Q hat. P hat is the hat you probably don't want to wear. Okay, there we go. Right, but it will. Too bad. This is called P hat and Q hat. So just like mu and X bar, P and P hat have the same relationship. P is for the population. P hat is for the sample. Let me stop for a minute. Oh, some of you guys look so enthused. Okay. So, what I want you to realize, earlier we started with this and we ended up here. We did a lot of adjustments and we ended up here. Is that an okay way to summarize what we did? Yes, because I was there. I'm the one who did it, so it's pretty much what we did, right? Even if you don't agree, oh well, it's what we did. So sure enough, we're not going to know the population average. Help me out. Remind me, what's the formula for the mean and standard deviation for an NPQ problem? It's the most beautiful little formulas. N times P. And the square root of NPQ. Kickins the ass in. Make sure I see it all for everybody. Hey, people at home. Stop watching Price is Right. Okay. Square root of NPQ. So, of course, what are they going to become for a sample now? One little tiny change. Mu is going to be same formula, but N times P hat. Right? Which is really, to be honest, I should use this symbol. And then what's this going to be? The standard deviation is going to be square root of NP hat Q hat. Okay. All right, let me stop for a second. So I haven't really changed the formulas fundamentally. It's just that I have to use the right symbols because we have sample probabilities now. We have these success rates and failure rates that we calculate from a sample instead of given to me about a population. Hasn't really changed anything. Okay, so what does this guy do? What's his purpose in life? He's trying to show such and so confident that we do what with this interval, that we catch the true mean. So are you guys cool if I do this? You can see what I'm just trying to say? Mu is kind of approximated by, in a sense, this. Mu is captured by this. Let me stop for a minute. I know you guys are so excited about this, I know. Does anything I've said right now made no sense? Hopefully it's made some kind of sense. You follow my thought process. You were here earlier, you know this thing we went through. We're gonna do the exact same thing right now. I just had to lay some groundwork. There's the symbol, because we're gonna get P and Q from a sample, so we gotta use P hat and Q hat. It's the first time we really had to do that. So we got those formulas, and now I know how to replace this stuff. So I want to capture the real mean. What's the formula for the real mean? NP. NP is going to be captured by this. I don't know this. I've got to use this, but what is that in terms of NPQ? Of course, what is that? That's going to be NP hat. So just like we took this and we replaced it with the shit we happen to know, we're doing the exact same thing for percentages. Now stay with me now. Plus or minus, good old Z is still the same as always. It's going to be determined by the confidence level, so it's not going to change its position in the formula. What am I going to replace this with? I've got to use the standard deviation I can calculate. What's that going to be? That's going to be that business. Okay. All right. Love you guys. So, I don't know if anybody's got an issue with this. I'm supposed to create an interval for a percentage, but right now I've got means. What letter do I want to get rid of? So I'm just capturing a percentage. N. If I get rid of N, doesn't that become a percentage? Yeah, so let's divide by N. Or maybe you see why I put this here, so I have two sides to work with. And again, what are we doing right now? We're deriving a formula that we're just going to use. I really want you to be with me on the derivation, but you're never going to have to do this kind of thing by yourself or something. always look at people's eyes, they're all like, how the hell am I gonna do that? You know, we're just creating the equation together right now. So the n cancels there, the n cancels there. What happens over there? The n's cancel. Yeah, so a little bit of algebra. Oh shit. I can't cancel the n's because the n's don't have the same root. You can't divide unless the roots are the same. What's 2 times 7? Holy shit, what's square root of 2 times square root of 7? Square root of 2 times square root of 7 is square root of 14, all right? Half of 2 times half of 7 is half of 14. That's really all that says. What's square root of 2 times 7? Square root of 2 times 7. I can't do shit there because they don't have the same root. Do you guys remember that at all? Must be the same roots before you can multiply or divide them. Vaguely, all right. Vaguely is better than none at all. Okay. So, n equals the square root of what? What does n equal to? The square root of what? I love it. You guys are like, how the shit would I know? 4 equals the square root of what? 4 equals the square root of 4 squared, 16, right? So n equals the square root of? Yeah. So I haven't changed anything at all by doing that. But the top and bottom both have square roots. I like it. All right, time to get it dyed again. The roots are shown. So, how many n's cancel now? 1 cancels. So what do I have left here now? I got z, yeah, plus or minus, z, square root of p hat q hat over the one surviving n. All right, that is a funky ass equation. That's the equation. That's what you plug and chug shit into. I hope so. That is the derivation of that. We're going to use this later. What does this piece of this really kind of mean here then? What does that piece mean? It's the same place as what? Standard deviation of all the samples. That's what this means. So later we're going to use this in a different situation with P's and Q's. We're going to steal this because this is basically the standard deviation of all the possible samples that I can take. That's going to come into play later. So if you don't know what I just said, don't worry. It's going to come back later. So let's do this last problem on this sheet. So can you guys do the first few steps here, if you haven't done that already? Figure out what p hat is. Please, dear God. Please, dear God. I'm always so sad that, and this is not your fault, people come out of high school, sometimes it is your fault. People come out of high school, they don't now have a clue how to do a basic percentage. So I put a little formula there, right, for p hat. X over n, the number of successes divided by total. But look at the sample. What's the percentage you can create? How many said they voted? Out of how many total? All right, that's how you make any percentage. Part divided by whole. Bam. Very unhappy that people don't know that. The more people that don't know that, the more I blame the education system. Oh well, shit. Oh, here's a little something. I might as well tell you this. P hat and Q hat, we're always going to take it at least 3 places. So what did I say on the very first or second day? I can't remember. You could take everything to 4 places except z-scores, and it covers your ass everywhere. Right? Why can't we do z-scores of 4? Because our chart only goes to 2. Okay, that makes sense. If you take everything else to 4 places, you're covered. Right? Standard deviation has to be at least 3. This has to be at least 3. So if you want to make it 4, tiers. Beautiful. I love it. So what do you guys get when you do 316 divided by 652? 0.485? Yeah, kick ass. All right, so I get to say my next little skit little thing. I don't care if they're wearing any clothing, socks, or whatever. P and Q have to add to be 1, no matter what clothing they're wearing. So they're wearing hats, great for them. What's Q hat got to be? Yeah, 1 minus P hat. So P sock plus Q sock. Thankfully, there's no P sock. At least not in statistics. I don't know about. I don't want to come to your house. So Q hat's going to be 0.515. Is that cool? Just 1 minus 0.485. I like it. And what's N? N, of course, is yes, not 316, right? People like to use that number. That's not N. N is the total number of things I'm looking at. So 652. All right, holy shit. Now we get a very exciting thing. I always forget about this until I see this and I remember, oh yeah, I'm going to talk about that. Okay, here we go. Do I still have a copy of this? Somebody have their copy of that thing. Take this out if you got it. The one with the pyramid in the middle. Remember the tossing a coin and it's got the histogram. Looks like a Mayan pyramid to me. You know what I'm talking about? Somebody have that somewhere I can borrow it? Pretty sure I don't have it.
This one?
Yeah, okay. Thank you. All right, so. Oh, shit. Somebody help me out. Does this look normal? Yeah, it looks really normal, doesn't it? So it's low. If I drew a curve over this, it would look pretty damn normal. Why? What's like the most important thing about a normal curve? The absolute single most important thing about it, something being normal. Yeah, but you can have symmetry and you just have to be folding on top of each other. Where's the highest point have to be? In the middle. You guys good? Now in this case, so what's the absolute lowest that the average could be? 0. What's the highest the average could be? 14. Right? So I could have a coin that somebody has weighted so that it comes out to be heads 90% of the time. You guys with me? So I can weight a coin so it comes out to be heads 90% of the time. Where would the highest point be then? If I flip that coin 14 times, let me capture what I'm saying. Mostly so I can remember. If I flip a coin 14 times and it's been weighted so it comes out heads 90% of the time, how many heads do I expect? You can do this. Yeah, right? What's 14 times 0.9?
12.6.
12.6. Now the highest peak would be at 12.6. And how much room does it have after 12.6? 14 is right there, right? So then the picture would look like, here's 12, here's 13, here's 14. The highest point would be basically at 13 almost, 12.6, right? That's the highest point, and then this one would be here. And then it's got like no room to come back down. Does that look normal? All right, do you guys see what I'm saying? Why is that not normal? Fundamentally because the highest point is not in the middle. I like it. But I mean, if the highest point was at maybe 10, maybe there's enough room to go up and come back down. And that's actually the key. Is there enough room for it to go up and come back down? Here, there doesn't seem to be. No. So here's the neat thing. Let me see. All right. Oh, shit. Okay. So what's got to be true is that NP has to be bigger than, I can't remember this book. Depends on the book. I'm going to say this. One book says equals there, and another book says not. NP has to be at least 5. So what that does, I don't know if you guys are going to follow. If NP is at least 5, it pulls it away from this wall. But as we see here, that's not by itself is not good enough, because if NP is greater than 5, if it's 12.6, that sucks too. So how do you make the other side work? Well, actually, the funny thing is, NQ has to also be bigger than 5. You know, at least 5. Because in this case, what would n times q be? It would be 14 times 0.1, 1.4. That's not big enough. So in order to keep it away from both walls, what the hell are those walls? Well, in a binomial problem, I have a certain set number of things. In this case, 14. So there's a 0 wall, can't go below it, and there's a 14 wall. So my peak has to be in the middle. How do you define the middle? 2 different directions. It's got to be away from that wall, it's got to be away from that wall. That's what those 2 things do. So so for a mean problem, x bar and mu, what has to be true for it to be normal? N greater than 30. To guarantee that it's normal enough. You with me? For a percentage problem, that's the correct test. Same result. If that's true, it's normal enough. I can use z-scores. Yay. If that's not true, I cannot do shit for a percentage problem. Okay, so let's look at this problem again. Let me give this back to you before I forget. Thank you. Oh yeah, you're just over there. Check, so when I say this, check those. In this case, I have to use p hat because I don't know what the hell p is. What's n times p hat? Well, what's really, really, really funny to me, let's just do this and then we'll see if you guys pick up on the shortcut here. What's n? 652. What's p hat?
45.
45. Some of you guys hopefully have noticed something about the math of this that I really don't have to do this work. If you do this work though, what do you get? 16. Of course you do. Sorry. Of course you do. Why? Because isn't p hat x divided by n? So what's n times p hat? Frickin' x. If you don't see what I'm saying, it doesn't matter. You could just do what we just did. So you get 316. Is that bigger than or equal to 5? Check. What about nq hat? Well, I would just do this minus this, because nq hat must be the rest. Or, yeah, you could do 652 times 0.515. What do you get? 335. And that's at least 5. Check. So that takes the place of n greater than 30. This check is a percentage problem. I can't use that same check. That's central limit theorem. It talks about means. I can use this check for percentages to make sure that it's normal enough. Okay. Concepts flying left and right. So therefore, I'm allowed to do something. If one of these was not at least 5, you technically cannot do anything. Because then it's not normal enough, and I can't do shit if it's not normal enough. All right. Now, how confident did I say I wanted to be? 91%. Take a minute and figure out what that z-score would be. Don't say anything out loud if you've already figured it out. Just sit there. All right, what do you guys get for the z-score? Anybody got that? Nobody?
1.7.
1.7? Okay. Crowdsource that. That sounds like something I gave on the practice test? How'd you get that, for anybody that's not sure? What's this area? Yeah, because it's half of the 9% that would be outside. So if you look up 0.045 in the z-score chart, you'll get negative 1.7. But why do I not care about the negative? Because it's built in. It's in there. It's in the equation already. I love you guys. So that part is the same as always. Z-score, don't care what's going on. All it cares about is how confident you want to be. That's how it tells you how far out you want to go. And now you just plug it. Now try to finish it out. Plug in everything we know in the right place. Figure it out. Create your interval. Oh. Get help from other people if you need to. You can call me over if you need some help. .045. So 0.045 is the closer you get to 0.045. It's an area, so it's going to be in there. Yeah, so it's going to be right there. See? Yes. Where are we at? 360. Yeah, if you do that, 652 times this. Get 316. Is that what you're looking at? 335 greater equal to 5. Greater equal to 5. Yeah, that's the test. Is NP and NQ, are they at least 5? That's the test. So 0.045, that's an area. Area during the body. So you're looking at the inside. So where's 0.045? Close to 0.045. It says O. So it's not going to be there. 0.045. You see the 0.4s. So you get the 0.4s. So where's 0.45? She's getting smaller that way. Yeah. Yeah. And see, that's closer than that one. So I'm going to use that one. 1.7. So we catch up to you guys. Right? That's what that is. Now what really, really sucks is if you get the equation set up correctly, but you put in the calculator wrong. Right? Garbage in, garbage out. So 1.7 times the square root. That's why this newer software is a little bit better for these, because you can tell exactly what's inside the root. 0.485 times 0.515. So I can see that everything I've typed so far is still under the square root. Now, if you have an older calculator that has a square root and then a parenthesis, do not close that until you get all that shit in there. The minute you close it, you're outside the root. That's the biggest mistake people make with this. Here I can see the big ass square root, so I know I'm still in there. So here's what I get for my error. So 0.033. 0.485 plus or minus 0.0333. Neato. So again, I'm going to do this. Store in x, 0.485 minus x, 0.485 plus x. All right, let me slow down for a second. Did we get that error? That's like plus or minus 3%, which is kind of, close to the plus or minus 4% they got up. It was written up here, that you very often see on whenever they have that news and articles and stuff like that. At the very bottom, oh yeah. So they don't just make that shit up. How sure are we, Johnson? Give or take 5%? No, it comes from the equation. And what's the equation? If I made my sample bigger, if I had a bigger sample, what would that do to the error? it would get smaller. That we knew that day one. Big sample, good, right? And that mathematically it agrees. It would make our error smaller. That's kind of nice. Math got it right. No way. All right, so let's see what we get. Here we go. 0.452 up to 0.518. Right? So what you guys get? 452, 518. Okay. Let me ask you this. This is a little bit weird. What did I say earlier that I don't want to be an asshole about? If you leave off units. The units in this case will be percentages. So you want to convert those to percentages. So we are what?
91% confident that the interval 45.1% to 51.8% contains the true percentage of people who voted.
Yeah, the interval, what I get? 45.2% to 51.8% contains the what?
True percentage of people who voted.
Good. The true percentage of Wisconsinites. I'm pretty sure that's how you say it. Wisconsinians? No, Wisconsinites who voted in the primary. Blah, blah, that's plenty. You got to capture the main idea of what it's going for. All right? We are 91% confident. Good Lord, Jeff. You know this is 91 because that's what you wanted, right? But you can't read that. You're 91% confident that the interval 45.2 to 51.8% contains the true percentage of Wisconsinites who voted. Yes?
So in this case, we're not talking about like a mean, we're talking about just some value we believe.
Percentage.
Okay, a percentage.
Yeah.
So
So-
we're trying to validate the percentage, not like a mean.
Yeah, in this case, this whole problem is about the percentage who did something. So it's kind of interesting. Parameter and statistic can be some numerical description. What are the two big ones? Mean and percentage. Right? Now, standard deviation is also a parameter in statistic, right? Sigma, and that involves a really funky ass distribution that we'll be discussing towards the end of this class. But I think that one's chapter 11. That's right. Sorry. Does that all make sense? Is that right? Okay. I love you guys so much. You guys are all like, no, but I don't know what to say, right? Okay. Now, where did this come from? Well, what's the error in this equation?